Okay, good. So till now, no, we have seen the statistics, which gives us an approximation to the population parameter, right? That's the entire scenario what we have learned so far. For that to achieve, we have seen so many like standard normal distributions, the Z-score, the point estimates, the confidence intervals, and so on. Like if finding the confidence intervals when variance is known, population variance is known, finding the confidence interval when the variance is unknown. So we have seen so many things, right? So our main intention of the entire things, what are the scenarios we have done so far, is to approximate to the population parameter. Yeah. So we have seen so many techniques, like from the stats, we have seen so many techniques there. So now the concepts which I have told you now, so those are like doing some statistical analysis part and all. Okay. So now we do that statistical analysis part or whatever, like standard deviation or whatever we are decreasing and everything, right? I mean the standard deviation to one and mean to zero and all. So those are certain techniques where those perform a high. We use them in a high valuable way so that we get good accuracy and good outputs actually. Okay. So now what we will do is we'll enter into a regression part. Okay, and then we'll start data pre-processing techniques today itself. We'll finish off the data pre-processing techniques today so that we can enter into machine learning from tomorrow because yeah, we need to complete off entire syllabus, right? So, well, from today on, we'll go a little bit fast and like I'll show you the code and I'll execute that and I'll explain you the data set and I'll explain you the algorithm and then we'll finish off the things. Clear? Okay. So let's first start with regression analysis. Okay. So regression. Okay. A technique for determining the statistical relationship between two or more variables, where a change in a dependent variable is associated with and depends on a change in one or more independent variables. See, so that's from the initial state of the statistics I was telling you, like take two inputs. If you find the correlation between the two inputs and the output, how could be the correlation? It might be a positive correlation, or it might be a negative correlation, or it might be like there is no correlation also. So regression is something where it's a statistical relationship between two or more variables. Okay, it's like regression techniques. Think of linear algebra, where we go with linear regression technique. Okay, so regression is a real like value kind of real value. Okay, real value in the sense it's a number. For example, take a data set with the salaries, okay, the salary and the respective positions. Like if you have reached to level one, this is your salary. If you have reached to level two, this is your salary. If you have reached to level three, this is your salary. If you're jumping from a different company into this, and what is the level they are in that company, and how much is the salary we need to hike it, kind of, the salary is the real time value there. Level one, level two, level three are the X inputs. Okay, that's how that's a relationship. From the levels and the salary, we have a relationship. So in that relationship, we are maintaining that relationship in a statistical way actually. Okay, that's what a regression is. Okay, technique for determining the statistical relationship between two or more variables, where a change in a dependent variable is just that's what. If you have a change in the dependent variable, uh, if it is depending upon one or more independent variables, like the x1, x2, x3 values, whatever are there. So if it is dependent on one or more independent variables, that means a particular relationship has been bounded together, and we are going to use that relationship for further purposes. Clear? Yeah. Okay. So let us see. So in regression analysis, when we start machine learning and all, we are going to first start with simple linear regression model itself. Okay. So here I'm giving you a basic summary about simple linear regression. But after completion of the data pre-processing techniques and all, then we'll go with the major part. That's it. In the machine learning, I'll teach you more more about simple linear regression, how it can be approached through Python and all. I'll show you that. Okay. So see, simple linear regression, how to build a regression, how to interpret a regression, how to compare models, multivariate regression model. Yeah. So simple linear regression model. So the simple linear equation, you already know the simple linear equation actually. So how we are going to build this regression is through the formula. Y is equals to mx plus c. As you all remember in the linear algebra, we used to learn this, right? Like y is equal to mx plus c is the equation for the simple linear, right? It's a straight line equation kind of y equal to mx plus c. So where m is the slope, x is one input, y is the output, and c is intercept, right? So how we are going to use these things to build a simple linear regression model? Okay, we'll look into this. Okay, two ways to find correlation between two variables. Okay, we have already seen this, like we have already seen the correlation, how to find the correlation and all, because the scale of correlation lies between -1 to 1, as we have discussed earlier previously, right? So if you identify the correlation between x and y, so if you're getting positive one, then that means the two variables are in relation, that is positive correlation, right? That's positive correlation. Okay, as you can see in the graph, zoom it guys, like in the graph, if you see, I already told you this, in the scatter plot, if you're identifying a diagonal kind of pattern, okay, diagonal kind of pattern in the data, that means there is a correlation between two variables. If not, we'll use these formulas. You remember, right? Like these formulas are the correlation formulas, which we have discussed in the statistics first session. I mean, not first session, in the first, what do we call? In the first topic. Okay. So see, so with this also you can identify the correlation between two like inputs. I mean, two inputs and output, like kind of. Okay. So a linear regression is a linear approximation of a causal relationship between two or more variables. That's the point. Same. Okay. See how we are going to do the process. Get the sample data. So whatever the data set you have now, we'll get that sample data, and we'll design a model that works for the sample. Okay. So design a model that works for the sample is, that model can be anything. So it might be related to linear algebra, or it might be related to entropy, or it might be related to probability as well. So we don't know which model is best suited for that particular sample data. And once we done with the model building, like if you're building a linear regression model, so once you're done with that linear regression model, then we are up to the prediction part. Make predictions for the whole population now. See? Okay, this thing, if you remember, in the students t distribution we have done it. Like in the students t distribution, what we have done is, like we have taken sample data set, and we don't know the variance of the entire population, and we want to approximate to the population parameter. So for that, we have derived confidence intervals there. But here what happens is, it gives us the estimate, direct estimate. This is the prediction value for that whole population. Okay, I'll show you, like when we enter into the machine learning models building and all, no, that time, you'll understand it very clearly. Okay, see, so this is the relationship actually. So this is the dependent. Y is the predicted value, that is dependent, and predictors. So the predictors are something where, I mean, those are like dependent to Y actually. I mean, independent variables only. Those are responsible for doing the predictions. That's why those are called as predictors. The inputs. Y equal to function of x1 comma x2 up to so on xk. So this f, the functional relationship, whatever it is, it might be any formula. So whatever you are using now, it might be any formula. If you want to use it for a simple mean, you can use it. So x1 to x1 x2 up to so on xk, you take the average for it, and y, the output y would be the average of all the inputs now. Right? The dependent variable y is a function of the independent variables x1 to xk. So n number of variables you can take, and the best possible mathematical logic you are going to apply for that functional logic now, that gives you a better output for the dependent y. I mean, what are the predictions you want? That gives us a better output. Okay, see. So here we have linear regression equation. So see, x1, x2 up to so on xk, we can have x1 also, right? So we can have a single value also, single variable also actually. So let us consider like we have a single variable, and we are building the functional relationship between the input and the output. There is y is the dependent, there is a prediction, and mx, x is the predictor here. As we have already discussed, y equal to mx plus c is the linear regression equation. Yeah. So here we are just summarizing the things, but yeah, when the machine learning concepts start, there I'll explain you how the prediction is done and how the values are being taken into consideration and all. But just remember this concept. Okay. Yeah. So y is equals to dependent variable, and x is equals to independent variable, right? Okay. M is slope and c is intercept. As we already know, these things we have already learned in linear algebra. So m is the slope and c is the intercept. That's a constant kind of. Okay. For example, take a data set. So income and education. Okay. So the more income you learn, if you have a higher degree, right? Suppose if you have only intermediate degree, then the income would be like around 10 to 15,000 per month. What if you have a BTech degree? Then slowly you'll reach to 25 to 30,000 per month. What if you have MTech degree, MTech or MS? Then the income increases. That means more education translates into higher income. That means if the income is the dependent variable, education is the like X input. If the education is increasing, the income is also increasing. That means it increases linearly, right? So that's why. So when you plot a graph between this income and education, see, we are going to get a graph like this. Okay. So lean. So this thing I will explain you, but see the graph. Okay. Okay. Check the graph. This is a linear curve. 1, 2, and 3. So these are the data points actually. So the gray points are the actual data points. Listen carefully, guys. This is very important because all the machine learning algorithm works like this only. Okay, for regression analysis. Okay, so the gray dots, whatever you're looking at, are the actual data points which are plotted in the graph, which are plotted in the graph. And the slope, from where the graph is starting, the angle between this line and this line would be your slope. Okay, I'll teach you that, but understand the concepts here. Okay, and the distance between from the origin to that particular point where it is starting is the intercept. Clear? Yeah. Okay, see, the main intention for showing you this graph is the orange line. What you're seeing is the prediction line. It's a prediction line actually. Okay, see, the line with the orange is a prediction line, and the gray dots are the actual data points here. Okay, so in a linear regression curve, obviously linear regression is a straight line, I told you. So the prediction is done in the form of a straight line. See, this is a straight line actually. Okay, think that this could be the best fitted line for this prediction from the actual data points, no? So consider that the orange line is the best fitted line, and this gives us the low error rate. So that's how we fix a prediction line here.
Sir, this point can repeat once, sir.
I can draw a line like this also, right? Check my mouse pointer. I can draw a line like this also, like this also, like this also, like this also. I can draw a line. But what is the best suited line for my data points to give me a good prediction? That is this orange line. Okay. Yeah. So how you are going to fix that orange line is the best fitted line for the actual data points? Oh, it depends upon the error rate again. The low the error rate, the maximum is the accuracy, right? So if you have a good accuracy compared to all the lines, this line has got a good accuracy. That means you are going to fix for this line, and you are going to do predictions with this line and with this slope in the future. Okay. So how we are going to identify the error rate actually? How we are going to identify this error rate? For example, okay, check this point. This gray point. Here I have already given it. Gray point, and the distance between this line and this data point. Okay, the prediction for this data points is here on the line. On the line, it has given us the prediction for this particular gray data point. Think that my prediction for this data point is here on this line. So I'll calculate the distance between the data point. If the error rate is less, like I'll check all the error rates and all. If the error rate is less for this particular line, then I'll fix for this line. Okay, and the prediction is done. See, if this is the point, if the new point has come up here, for think like if the new point has come up here. Okay, the line, I'll draw like a perpendicular line to that particular line, and see, you can see this. Suppose if you want to do a prediction here, I'll draw a line till here, and I'll go till like this, and I'll find the value here, and I'll come here and I'll find the value of x also here. So I'm going to predict out the y with this x actually. So that's how you do the predictions in real time in machine learning. Okay, so this is what I mean. This is something about the summary of the linear regression model. Yeah, don't worry, this is a little bit complex. Like first time when you're listening to this data science topics and all. So when we do this in a practical way, then you will understand it very clearly. But meanwhile, just understand the concept, like understand the graph. That's it. Okay. So till now, we have finished out the statistical approach. Whatever the statistics are needed for our learning, for our syllabus. I have completed that. So now we'll enter into data pre-processing techniques. Okay. So in the first sessions of data science, I told you data pre-processing techniques are also very crucial steps. Because data pre in the steps only we clean the data properly and we try to train that to the machine for getting good accuracy. The garbage in is equals to garbage out, if you remember. So how much the garbage you feed to the machine, the output will be also the garbage. So in order to reduce the garbage, I mean like reduce the unwanted things in our data set, so we go with this data pre-processing techniques, like eliminating the outliers, kind of. Are you getting my point? Like checking out the missing values and okay. So there are certain data pre-processing techniques. We need to understand that. So let us see step by step. Okay, first we'll understand what is data pre-processing here. Okay, data pre-processing is a data mining technique that involves transforming raw data into an understandable format. See, into a clean, understandable format. We are transforming the raw data into clean and understandable format. Real world data is often incomplete. Sometimes it might be incomplete, inconsistent, and or lacking in certain behaviors or trends. So we need to create trends at that point and is likely to contain many errors. Right? So data pre-processing is a data mining technique that involves transforming raw data into an understandable format. Understandable format in the sense the data can be incomplete, sometimes inconsistent, and or lack in some behaviors or trends or patterns, and is likely to contain many errors. That's what many errors is again the garbage thing. So in order to reduce these all, like to make it perfectly understandable format, we go into this data pre-processing techniques first. That means before entering into machine learning, we need to do this data pre-processing techniques. Clear? Yeah. So what are these data pre-processing techniques? Okay. Steps to be followed. So we need to import the libraries first. Okay. We should import the libraries first, and then we need to import the data set. So data set can be in any format. It might be in the database, or it might be in a CSV file, or it might be in a like what do you call it, Excel file, or it might be in log files, anything. So you need to import the data set accordingly. Okay, we have all the CSV files, so I'm going to teach you the entire sessions with the CSV files only. So we are going to import our data set with pandas, the CSV format, right? Read CSV. Okay. After that, we have missing data. So these are the processing steps actually. So if you have missing data present in your data set, how you are going to like solve that? If you have missing data, how we are going to solve it? And if you have categorical data, how we are going to solve it? Categorical data in the sense the text part. Suppose yes or no. You have yes and no. So machine can't understand directly yes and no, right? It understands only numbers. So how we are going to solve that? Like how we are going to take that categorical yes or no to some other kind of numbers and all. So that process is also involved. And training and test set. This is where you take samples for training and use the test set for checking the accuracy and error rate. Clear? Yeah. Feature scaling. So this is like converting the scale actually. So the standard normal distribution which we have seen, like converting the mean to 0 and standard deviation to 1. So this is that process. So these four processes are very crucial. So no need to apply all the
Sir,
four processes. Yeah.
sir,
Yeah.
training and test set, sir, can explain one, sir.
Okay. Training and test set. Okay. Training and test set is something. Suppose you have a population. So you have taken some part of the population for training the model. Okay, after training the model, you need to check, right, how accurate the model is. So we'll use some part of test set from the population. We take the test set and we predict the outcome of the test set actually, and that means we give only the inputs. So we already know the outputs that we have. Y is the output, right? So output will keep aside and will provide the inputs to the machine, and it gives us the predictions value. So those predictions values I'll take and I'll compare it with my actual values and I'll check my accuracy. That's how I'll fix them. I mean, that's how I can understand how my model is, right? How accurate my model is and all. If my model is not accurate, then I'll change some certain points and then rebuild it. For that, we use this training and test set. Definitely, we need to use this training and test set properly. Like people often use 80% and 20%. So 80% of the data set they take for training and 20% of the data set for use for test set. Usually, you can use 75, 25 also, 90, 10 also. But universally, people go for 80 and 20. Okay, feature scaling, the standard normal distribution, which I have told you, right? Yeah, standard normal distribution, which I have told you. So we'll see. Like, see, sometimes you don't have missing values, then no need to perform the missing values data pre-processing techniques. That avoid that. And if you don't have categorical data, avoid that. If you want only training and tested and feature scaling, do it. That's it. So how to do the process? How to do the process of this entire means if you have missing data, if you have categorical data. Okay, I have a small data set. Let us check this data set first. Okay, see. So we have a data set here. We have country, the columns. Check the columns first. Understand the data. So we have country. That means yeah, we have country data points, age, salary, and purchased. That means the insight what I got from the columns is for a particular country and for a particular age, if the salary is this much, is the person going to buy the product or not? Is he going to buy the product or not? Right? Sorry. So there's a mismatch in the rows. I'm just replacing that. Okay. So that means purchased is this is a categorical data, right? As we already discussed. See, yes or no of the categorical data. Yes or no is a categorical data. Again. Okay. And we have salary, we have age, and we have country. Can you find any missing values present in the data? Yes, we have a missing value here. We have missing value here. And country is also categorical data. See, France, Germany, Spain, right? Categorical data. So this falls under categorical data and data preprocessing techniques. This falls under missing values. And okay, so see, age and salary, like if you compare them both, no, there's no relationship because age is 44 and salary is 72,000. That's a big number. That means outliers. That those are not in a perfect sync actually, right? So we'll bring down these two scales into common scaling. So here we'll apply feature scaling and then we'll go with train test split. I mean, before feature scaling also you can go. After feature scaling also if you want, you can go. That's okay. Okay, right. So we'll start with missing values with the Python code. Okay. So the first step. What is the first step? Import the libraries. Exactly. So what are the libraries we require? Let's start. So we need pandas to import the data set, and we need NumPy. As I told you, we convert everything into NumPy math arrays, and then we train the machines and all. Right. As I told you, we need these two. Initial, yeah, for the initial state, we need these two. Okay. Yeah. So this uh,
Sir, your voice not audible, sir. Sir, sir, your voice can't audible, sir. Sir, your voice can't audible, sir.
sorry, yeah. So yeah, so the code whatever you're looking is the old version actually. I mean the package is updated properly. These are the old PPTs actually. That's fine. I'll show you the latest code actually in the Python file, and I'll share that Python file with you guys. Okay, is that clear? Hello.
Sir,
Yeah. Okay. So we'll start. So we'll fill the missing value. Yeah. If you have any doubts,
sir, how to include the library, sir,
how to
into that missing file, sir?
how to what's that?
Sir, import libraries in missing data, sir. How it, sir?
Yeah, that's what I'm importing the library now, and with the library module, whatever we are importing, we'll use that module called imputer, and then we'll fill the missing values. So I'm showing you that only. Okay, I'm showing that from. Okay, once you install scikit-learn, sklearn is the module name actually. The module name from the sklearn dot impute. I'm going to import my simple imputer. Okay, simple imputed. Now I'm executing this. Yeah, so my module got imported. Now what I will do is I'll create an object for the imputer. Like what is the exact thing you need? You want to fill the values with the mean and for the nan values, right? That object I'm going to create, and I'm going to store it in a variable called imputer. Okay, see, I'm going to use simple imputer. Good. And inside the simple imputer, we have parameters kind of. The parameters are like if you want to fill the missing values. Yeah. So what is the pattern of that missing values? So we need to give the pattern for the missing values. Since we are using numpy array, check this here, guys. I'm typing something in the console. np.nan gives me nan. Okay. So that's what I'm going to type here. np.nan. That means it need to identify a numpy. I mean the numpy array is we are sending the numpy array and it identifies the nan value present inside that numpy array. Okay. Yeah. Good. So next, after finishing that, what is the thing you need to apply? The mean, right? So for that, the parameter strategy, I'll be typing as mean. Okay. Now my imputer object is done. So the imputer object we are telling that imputer object find the missing values with the pattern nan, and you need to apply the strategy mean if you find any nan values. Okay. Yeah. My imputer object is built. See, simple imputer object of sklearn.impute base model. It is built. Now I'll deploy this imputer object on top of my what, like on the x, on top of my x. Okay, so if I deploy that, think like this: x is down and the imputer is on the top. It superimposes with x and it identifies nan values whatever it is there, and it uh, averages the value, and it the missing values will be replaced with mean actually. So how to do it? Okay, how to do it? Okay, first you need to understand uh, like we need to fit the, what do we call, the superimposing thing what I was telling you. We are going to fit my imputer dot fit. So we are like adding a layer on top of the x. So to which values you need to add on top of the x? Let's see. I'll go to my x. That is 0, 1, and 2, right? Right, columns. So only the columns to which I need to apply my imputer, the 1 and 2, the 1 and 2, right? So I'll select the values with the columns 1 and 2 and all the rows. So x. So we already know now that the multidimensional slicing we have used in NumPy. So I need only the last two columns. I'll use 1:3, the index 1 and the index 2. Okay. Now I fitted my layer. I fitted my layer on top of my x, the imputed layer. Now I need to superimpose that layer so that it converts the entire nan values into mean. How to do it? See, it's very simple. You need to first mention to which columns you are going to apply the imputer equals to, and on top of that apply imputer dot transform in the sense then it transforms the nan values to mean, to which again x is to comma 1 comma sorry 1:3, right? Now here
Sir, your voice can't audible, sir.
okay, yeah. So the next step, categorical data. So see, the France, Spain, Germany, or the output. Why we have no clarity. Like it's not. It's an entire categorical data, right? So we don't know. So machine will not understand. Like if yes or no, there are only two variables. That's fine. But what happens if you have more than three categorical variables, right? Okay. For that, any categorical variable. First, we'll try to convert that into numbers actually. Okay. In order to convert that into numbers, we call that process as label encoding. Label encoding. Okay. First, we'll start with our label encoding. Uh, yeah, here it is. Categorical data. So categorical data represent types of data which may be divided into groups. Examples of categorical variables are race, human race, male, female, trans, everything. Sex, male, female, again, age, group, and education level. Okay. Yeah. Again, hold on for 1 minute, guys. Okay, yeah, sorry. So categorical data. So like different categories, like yes or no, or the car brands, Audi, BMW, we have discussed, right? Steps to be followed are finished till missing data. Now we'll, as you already discussed, why we need to encode categorical data. We use label encoder to class to encode this categorical data. Okay, so first we'll try to label encode it, and then I'll discuss like why we need to encode the things and all. Okay, okay. So first we'll try to label encode it. So how we are going to do it? Okay. So the first thing again, we need to import the packages for label encoding. That is from scikit-learn itself. So I'll use from sklearn dot pre-processing. Yeah, I got the module. Import label encoder. Yeah, I have the I've imported my label encoder now. Okay, so I'll create an object again same thing. I need to create an object for that label encoder, and I'm going to superimpose that label encoder